Hello, everyone. My name is Nina, and welcome to the second webinar of our Dissecting Diversity series, where we introduce leaders who are actively working to increase diversity in science. Today, I'm very excited to introduce Dr. Zaelzer, who is a neuroscience researcher at McGill University, a lecturer in the Faculty of Fine Arts at Concordia University, and the founder of the Convergence Initiative, which is a nonprofit organization that promotes transdisciplinary work among scientists, designers, and artists. Today, his talk titled Boxes, Closets, Academy, and Other Containers will touch on the relation of science accessibility and diversity, focusing mainly on the use of fine arts in design to generate better communication with the public. For all our audience members, please feel free to type any of your questions in the live stream box, and we will try to get to as many as possible at the end of the talk. So without further ado, please welcome Dr. Zaelzer.
Hi, guys. So thank you so much for that nice and kind introduction. I'm really happy to be here. Quite excited, actually, to talk a little bit of some ideas that populate my mind and some of the work I've been doing to try to consolidate them. So I'm going to share my screen and talk a little bit. So can you see that closet? Yeah, perfect. So my talk today will deal a little bit with precisely that image, and I will talk also a little bit about me, just as a way to explain why this is important to me and why I use this as an example to the importance of change our mind about the way that we approach science communication, science teaching, and science learning. So I'm going to start. So as I say before, the talk is called Boxes, Closet, Academy, and Other Containers. And I am Cristian Zaelzer, PhD. I'm research associate in the Research Institute of the McGill University Health Center. As Mina say, also lecturer at Concordia University Faculty of Fine Arts, and the founder and president of the Convergence Initiative. And I'm going to start this talk today just defining first what is a box. So a box, according to the Merriam-Webster dictionary, is a rigid, typically rectangular container with or without a cover. However, there's another exception to this particular definition in the dictionary, that is the limitations of conventionality. And this particular definition is very interesting to me because it can very much to speak about the subject that we're talking today. And you can find boxes that are pretty regular, right? Like this cardboard box is kind of the typical box, but you can also find extremely beautiful and ornamented boxes. And no matter what, they still are boxes. They serve a particular purpose. And that purpose is usually categorization. So you use boxes to put things and organize them and understand them. And this is not intrinsically bad. It's actually good. We can kind of navigate our life, understand better the world around us by categorization. The problem is that we use boxes also to categorize people. So like, for example, when we see this photography, we're saying, okay, this is an artist and belong to the category of arts and humanities, and the abilities that the artist have our emotions and feelings. Meanwhile, this other guy here is a scientist and belong to the category of STEAM. And the abilities that this person has are reason and critical thinking. So we categorize in boxes and we put people in different containers. The problem with these containers, with these boxes, is that not everything fits in a box once you create a category. And the other problem is once you put someone, especially someone, when we're talking about people, in a category, it's pretty hard to remove that person from the category, to get out of that. Now, I have pretty much experience with being in boxes because let me explain a little bit of my story. So I born in Chile. Chile is in South America. South America is a very conservative place, a very religious place. It's Catholic or Protestant. I was raised by a single mother, so I didn't have a father, the figure of a father to take care for me. So that was already pretty complicated. We were particularly poor, so I grew using the clothes of uncles or clothes that we received from donations. And I was Jehovah's Witness. So all this combined was predicting that my future will not be any near to being outside of my country and being a scientist. And even to make the things worse, when my mother was 55 years old, she passed away, and I was 18. So the situation of poverty, the situation of being raised by a single mother in a very religious environment, makes things already complicated in the terms of accessibility and things that I was supposed to do was an additional problem. I realized that I was gay. And actually, I fall in love with a person over there in Chile. And after being in love for several years and tons of trouble, because I come from a region that is, let's say, like the Texas of Chile or the Alberta of Chile, like a very conservative, with people that dedicate pretty much like a livestock. And, the idea of masculinity and who is a man, who is not a man, is a very strong concept in Chilean culture, at least 13 years ago when I was there. And jokes were made about gay people. And if you were gay, we were immediately in this category of jokes and rejection. So, and I was in love with this person, and our story was awful. At some point, I was even kicked out from the house of him by his mother. So all this experience, terrible experience, made me just to come back inside of the closet. And I stayed in that closet very safe and sound for several years more until I came to the United States to do my PhD. So from around 20 something to 30 something, I stay in that container. And this affect particular my possibilities to being a happy person. I'm a happy person in general, but I could be happier, have a better experience if any of these barriers, any of these boxes would not have me put and hold for my happiness. And I have also problems to fit with the typical scientist because I'm not also the typical scientist. I love sci art. And since I have memory, I love science and I love art. I wanted to be a naturalist when I was 7, 8 years old. And at the same age, I was painting and doing little exhibitions inside of my bedroom. And you can check a little bit in what is my CV of the stuff that I've done over my life to understand that it's impossible to me to just do one thing. I learned coding in high school. I was graphic designer and art director when I was young, around 18 to 20 something. Then I became a medical technologist with a bachelor in molecular biology. I'm a bagpiper. I have a PhD in molecular and cell biology. I become the founder of Convergence. I'm art science advisor to the Faculty of Fine Arts, and I'm a stained glass artist and an acrylic artist. That you see over there is one of my paintings. So I like to do so many different things. I don't fit too well with boxes, and this has been a problem actually with academy also to accept what things I can do or which things I should not do. Now, I was told also in Chile, people believe a lot in the idea of individualism and meritocracy. They believe that you as an individual can achieve whatever you want. It comes from this idea of the American dream, right? Like you can achieve whatever you want just if you work really hard. It all comes with your merits and your hard work. And the truth is, over the years, I realized that this is not true. It takes a village to raise a child. And when I say this, when I use this old say, is because we know, especially that you that came today here to talk about esteem, right, and diversity and LGBTQ2S, we know that things like your race, your gender, your sexual orientation have a huge impact in how successful you will be. Indeed, also your social economical stance have a big impact. I'm a weird story. I should not be here because I was raised in a really poor family. So I'm an exception, but most of the people that have the story I have, they stay forever in this cycle. They cannot break the cycle of poverty, and they stay there. Also, it's important who supports you, who is around you. Like in the moment that you guys arrive to university or decide to do graduate school, who supports you, who supports you in your family, also will influence if you're successful or not. The network that nurtures you, what you watch, what you read, who you talk to, and your mental health, which is even more complicated, right? Because mental health issues are invisible. So you can be having a huge weight over your shoulders and no one will know. And all these factors here, these 5 points I put here, will determine if you are successful, and has nothing to do with your wish to just succeed. You can work as hard as you want, but if all these things happen, we know that you will have less chances. So the question that comes now is, we come back to the box. Who fit in the STEM box? And this is the hard truth. The STEM box today is filled by dudes that are white, that have high income because they have the power to buy education, that they come usually from developed countries, Canada, US, Japan, Germany, UK, France, and they usually straight, right? They don't have to deal with all the issues already that we have in the head when we have to deal with being gay or lesbian or any of the categories that we have in LGBTQ2S. They are free from that. And this is most of the people that fit pretty good in the STEM box. So everyone else will have harder time. So STEM today is not everyone's commodity, and that's the truth. And I got in the issue of how to make science more engaging. I started to do this 5 years ago, and I realized in the road that this was not just an issue of communicate science. This was an issue bigger than that, and it had to do with diversity, and it had to do in how many people you include to give an opinion. And here I talk a little bit. I mentioned Harding and Haraway, who are two feminist philosophers of science that talk about the importance of include other point of views than except, a part of the white, male, straight, who already permeate science deeply. Because all these other point of views that come from gay people, from black people, from indigenous people, from people with different histories, will bring to science all these elements that we don't have. The science that we produce today is pretty much white. We forget all these other areas that are so important that come from this other variety of people that is not included in the scientific discourse. So that said, the problem is still, how we communicate science. Because if we can communicate science effectively, we can reach people with ideas of science and give people the power of knowledge. And with knowledge, you create equalization among people. So if you can access to science, you can access also to all this knowledge, improve your quality of life and improve the quality of life around you. And I focus in particularly in emotional detachment in science communication. And I did this because the way that we create science today is pretty much based in determinants that make science being absolutely not emotional, just factual. And we have a big problem with that. And the main factors here are deficit model. That is the way that we learn and teach, and means like when you don't know something, a teacher, a communicator, or a scientist will come and tell you, this is what you don't know. Leave you the comment, the knowledge, and leave. We are communication clueless in science. We don't have any particular formal training to communicate effectively with people. It's not in any of the branches of formation today. You don't see it when you go to university. You don't see it when you go to do a PhD, a master. It's nothing there. We are slowly trying to move towards a better ways to communicate science because it's crucial. We have problems with the knowledge paradox, which means that more we know, harder it is for us to explain this knowledge to someone that don't know. And we all suffer of confirmation bias, which means that once we know something, we support this idea and we consume more information that just support that idea. So it's hard for us to change our mind with new information, even scientists. So, and this will happen not just us, to everyone in the planet. It's a cognitive bias. So that said, I want to explain why all this is so complicated for us and why we have to do so much with science. It has to do because the way that we construct the scientific knowledge, the scientific method, predispose for that. And this doesn't mean the scientific method is bad. It's actually super successful, as allow us to know so much. But for communication, it's complicated. The scientific method started with Bacon, who talked about the ideas uh, to that everything is gained by experience, that we need to experience in order to learn new knowledge, and followed by Locke, who also thought that just experience is the way that create new knowledge. Then Hume had the idea of experience and inductive reasoning, and he talked for first time that the way that we reason is pretty much driven by emotionality. And because it's driven by emotion and by habit, we have to do something to allow get out of the influence of emotion to make the method unbiased. Popper bring the idea of disprove an hypothesis instead to prove it directly, disprove an hypothesis, which complicate pretty much the idea of how we communicate and how we understand science with the lay person. It's already pretty counterintuitive. The Lewis say that every time that you touch a system, the system already is changed. So you have to do in a way that you create counterfactuals to develop a better understanding of the scientific knowledge. And finally, Kuhn say that the way that we produce knowledge today is just based in knowledge that we already know. We don't create really something new, but we just repeat over the base of things that we are not proving again if they are real or not. He talked about changes in paradigm. This make science, the creation of science and understand science, a complicated cookie, for saying other words. And that's why you need between, I mean, you guys do 5 years to 6 years in university, then you do 2 years of master. This is already like 6 years. Then you do a PhD, it's 4 years more, 4 or 5 years, so it's 11. And then many of you will do a postdoc, which is 3 to 4 to 5 years more. So you experience around 15 to 17 years just learning to be a scientist, to learn the language of science. So when you have to talk to people outside, you speak in science, you don't speak in human. And that's why science is so complicated to communicate to other people. People just like look at you like, who's this guy? Which planet come from? Now, the truth is that our brain don't work as a scientist. That's why we need the training. Our brain instead uses other type of knowledge, not just the factual knowledge, but knowledge about other things, spiritual knowledge, the knowledge about nature, the knowledge about tradition, other type of way to see life. Our brain is designed to use emotions also to understand better what happened around us. And indeed, emotions control most of our decisions. We, because use emotions, are keen to mistrust. Our brain keeps us always in high alert to know when something is dangerous. And because this, we also behave as a group. And as a group, right, we protect each other. So when someone in the group sings something and everyone starts to support the group, you can be completely wrong and still you will be believing what this person is saying. And this was proved pretty much really in a beautiful way by Solomon Asch in his experiments about group psychology, how you can change your views. And he did the following experiment. He put 6 people in a room and he put different bars of different sizes. And 5 of these people was just acting, and 1 person was the real experiment. And at the beginning, these people was telling, I see this size, I see this size, I see this size. And in some point, they purposely start to give wrong answers. And the evaluation was to see what the person that was in the experiment was going to respond. And the thing is that the person that was doing the experiment started to change also his answer, even when he knew that was wrong. Ash demonstrated that we change our way to respond when we are in group. We are no longer individuals. We are part of a group, and that's the way that we humans work. And even if you give a fact, this is not going to work when you're in a group. The same thing is related to the way that we recognize patterns. Sorry, not the same thing, but the brain uses pattern recognitions to understand the world around us. And this means that in some occasions, this pattern will be wrong recognition and will still go, with this answer because it's the one that less energy provoked to your brain. We use for that something that's called heuristics that allow us to select from different answers, knowing that some of the answers already have been effective for us in the past and allow us to save time and energy. And finally, as human beings, we like to be in control, and we lack the control. We enter in a state that is pretty much cathartic. All these points that I mentioned here go pretty much against what we learned in the scientific method, that is respect facts and use facts to take decisions. We as humans don't use too much the facts, but use more the emotion and how we feel in relation with the people that's around us. So it is important for us to understand as communicators these aspects of our constitution as an organism in order to understand better how to communicate science. Now, interestingly enough, we usually see a big gap between science and art. And we judge arts as being very emotional and science as being very logical. And this apparent gap that exists between these two disciplines is actually what I'm using to make a bridge to communicate better the science. Because I told you before that I'm interested in how emotions play a role in the way that we understand and accept knowledge, and how we can use emotions to communicate better, to arrive better to the person that you want to talk to. So I'm going to show you very briefly today 4 different examples of how we can use art for this. One is to decrease anxiety when we communicate. Another is to promote trust when we communicate our science, by triggering pleasure, and by promoting introspection. So these examples that I will show now are experiences of art that are being studied in the way that our brain reacts to this. And I will just a little bit of why then use art to communicate science, or use emotionality to communicate science, is particularly useful. So let's start with decreasing anxiety. As been shown, these are 2 examples here. The examples are testing textures in the first diagram that you see here in the same experiments, and in the other one is testing colors. So in the one where textures were tested, they were tested textures that were smooth against textures that were rough and hard to the touch. In the case of the colors, what it was testing was colors that were harmonic against colors that were really disharmonic with the full frame that was presented to the people in the experiment. In both experiments, what the result revealed is that it's a big role in an area of the brain called the amygdala and the insula. The amygdala is pretty much related, even when have many other functions, but it's pretty much related with how we react to situations that are risky or that provoke on us fear. And indeed, when you are touching a texture that is kind of not smooth, the amygdala will be active. And the same will happen with when you are experiencing disharmony in the colors. At the same time, another area that is related with disgust, with things that provoke us, rejection, and try to get apart from that, get active when we're experiencing this not so satisfying experience of color and texture. Meanwhile, when you experience textures and colors that are harmonic, areas of the brain related with reward get active. So in other words, if we bring this to the practical issue, if you're presenting your science and you're presenting your science with an horrible graph, with an horrible disharmonic colors, with horrible typography, you probably are already making your listener get rejection instinctively. It's nothing of reason in this. This is something that your brain just reacts instinctively to this information. Instead, if you use something that is harmonic and beautiful, aesthetic, you're already bringing and giving a step forward to engage your audience. Second example, promoting trust. Most of the activities that we do in art are social. Most of them are experiences. Most of them are things, like going to a theater, watching a movie, listen music. Now, why are they interesting and important if you want to use them as a medium to express or talk about science? Because when you promote trust, oxytocin, the hormone of love, even when it has tons of different functions, get released. And when it get released, oxytocin go and bind in the amygdala and have a modulatory role in the amygdala. And basically what it does is reduce the activation of the amygdala, making, situations like fear or anxiety also reduce. What is interesting also is that the amygdala have huge connections and talk to memory, to the hippocampus, and also to the circuits in the prefrontal cortex. So when you have your amygdala active, when it's like boom, 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 because you're scared, all the circuits are more in charge to save you and keep you out of the risk than thinking. So if you, and from this is many research about that. So if you are able to reduce the anxiety by producing oxytocin, you will be able to change the way that you remember things and change the way that you react and reasoning about things. So promoting trust is extremely important to communicate science. Recommendation: never go with a bunch of facts to talk to people and get kind of like, oh, I know and you don't know, because that will do exactly the opposite that we're seeing here. Next step: triggering pleasure. There's studies like most of their appreciation, like we are going from faces all the way to music, trigger pleasure. And these here are just like different areas in the brain that are related with that. Pressure, pleasure, reward, and motivation are extremely bind together. In this particular example, when you listen music, first, when you are anticipating the music, your brain is already activating parts of your creating attachment, approach behavior, getting interested in what is happening, get ready to move. And then when the emotional peak happens, when the music is in the best point, you get activation of something that's called the nuclear accumbens, which is related with motivation, aversion, positive reinforcement, and reward. Pleasure, desire, positive reinforcement, that will drive you to learning. Finally, promoting introspection, and this is extremely important. When you experience art, you are also activating an area of your brain, a network. From the many networks that we have, one particular network is called the default mode network. This default mode network, what it does is work in your brain when you are basically not really thinking hard in a problem. It's the network that will be acting when you are just like a mind wandering, leaving your thoughts go around, daydreaming. And this particular network is extremely important. These are the connections that the network has, which are extremely big. This network will be extremely important for things like memory retrieval, autobiographic thinking, emotional salience, understand the space where you are sitting, space exploration, images strategies, the way that you appraise emotions, the way that you encoding things like the value of emotions, and at the same time, all the cortices related with sensory. So it will also trigger things like introspection, which we really want when you are talking about science, right? Like how science can change and modify your life, how it can improve your life, how you can create new things, how you can imagine new futures. So I want to show you this model. This is the model I am working currently today. I think that when we talk, how are we of time, Mina?
We have you can speak for another 10 minutes.
Okay, perfect. So this is the model I work currently today. I think that we as scientists create science in a base right of experiments, technology, knowledge, scientific base, and a lot of jargon. That's the way the scientific knowledge is produced today. And all this is put together in a pretty much in a way that lack accessibility and emotionality. These are the two little shades of blue that you see here. Now, this is pretty good for academic communication, and it's actually necessary because in the different fields, you have to have the different codes and language that will allow you to produce the knowledge without any problem. The problem is when you want to bring this knowledge to the public, you cannot use this area of the circle because jargon become a barrier. So to do this, to be in this area, when you go to media and education, you have to reduce the jargon to the minimum. And I think that graphic design is precisely that Rosetta Stone, that pivotal moment where you reduce the jargon, and because you reduce the jargon, you make now the knowledge more accessible. And at the same time, because you use, we were talking about colors and textures and all that, you make the science also more attractive, more emotionally attractive. So this knowledge is ready for media and communication. Now, when you want to really reach the mass, you go further with more emotionality that will promote more accessibility. And that is through the lens of fine arts. You will remember better scientific knowledge through a movie, through a comic book, through a novel, through a play, through music. And you see here that jargon almost disappeared and science get a little bit more tiny than was at the beginning. And this is not necessarily bad. This means that the key messages of science are being conserved while you put all this adding of accessibility and emotionality that allow us to communicate to the public. This is extremely important because then the public will have influence in decision makers, in the people that actually will give money and will understand how the science is produced. That will affect the way that we scientists get funds to do more science. And this is also the way that we will make accessible science to other people. When you create science that everyone can understand, you arrive to everybody in the community, not just the people that have the best education to go in this area, right? As we were talking at the beginning. Just people that go in university will probably access this part. Like you guys here are watching this. If you're in university or your PhD, you are here, or your master. So you understand. You have the privilege to have the money, to have the resources, to have a family that was able to pay for you in most of the cases. Probably a couple here are doing it by itself, but most of the people have parents that will allow you to access here. Most of the people, however, is here, right? So if we want to improve the life of everybody else, we have to write to this aspect of the knowledge and the communication of the knowledge. So then we really can influence politicians. Politicians are there just to understand what people want and what they need, what are the needs of these people, right? And they will give more money for invest in science, for invest that finally this will translate in investment for the country, improve the life of everybody else. But if people here don't know and have no access, this is not going to happen. So just to finish, I want to talk a little bit of what I do at Convergence. So Convergence is this precise idea of put science and art together to develop this kind of models. And what I have done here is just, following the words of Angela Davis. I'm no longer accepting the things I cannot change. I'm changing the things I cannot accept. I think that we have, as I said before, a horrible way to communicate science today, and we have to change this way. What we do in Convergence, one of the things that we do is put scientists and artists to work together. We have the cooperation of different agencies and institutions in Montreal. This is based in Montreal. And we have established a course in Concordia University. This course is already, this is the 4th year that we do it. These are some of the posters announcing the course. And what we do in the course is, this is my colleague that we teach the course, Bettina Forget. And what we teach to the students is a combination of things between neuroscience and the practice of art. Each one of the topics that we cover here goes from one side about the science and one side in relation to the art. We talk also about philosophy, about how science is constructed, and then we teach our students to use factual knowledge with creative knowledge to create better and different tools to communicate science. In the second semester, what we do is produce art. And I just want to show a little bit this. There we go. So we produce art. This is the people in the course. We produce different aspects of art and science combined, and each one of the students make a team with their counterpart in science. So we have teams that are composed by scientists and artists, and they work together in equal conditions, learning from each other, transferring knowledge from each other to create project of arts that are based in the science of the group, but are questioned by the point of view of the art. And let me tell you, the ideas that artists can bring to the table are incredibly interesting, and they bring right away different ways to think and really think out of the box. So we're talking about boxes. They can really help you to understand how to think out of the box. So what you are seeing right now is part of the classes. This is the class, or one of the classes of science communication, where we are talking about information and how information is processed by the brain. So at the end of the second semester, our students will produce pieces of art, as I said before, and I will show you here in the video after we see these little slices of the graphic design class where our students are learning graphic design. We visit labs. You see here some of the tours to the labs. This year, of course, is going to be harder because COVID, but we usually bring our students of art to the science labs. And also we bring our scientists, students to the studios, and they create in those studios. They learn what artists do, what is the research that the artists are doing, and it's extremely, again, interesting. So the research go from simple creation to really research in how art can change the life of people. We do debates, we discuss topics that are a little bit more controversial because we want our students being able to discuss subjects with other people, especially those subjects that are complicated. And finally, how we go here. There's some of the teams. I just want to arrive to the part where you will see some of the artworks. That's the science symposium. We also teach our students to talk about science with the different methodologies, not using the typical talk, but actually using performance and storytelling, creation of pieces of art, music, and these are scientists that you are watching right now in this part of the video. And then let's see if I show it now. The exhibitions. Those are the exhibitions. So we invite people to experience exhibitions of art created based on neuroscience. These are the exhibitions from 2019. The last in presential exhibition that we did before COVID came, where our students create different projects that they go from, painting and sculpture to actual installation, intermedia, and really using sensors or high technology to express art and performance. So all this happened in 2 semesters. And we are extremely proud to have thousands of people visiting these exhibitions every year. So our objective is just to create divergent and convergent thinking and reduce the fear to talk in public and talk differently to audiences, think out of the box, learn that not everyone speaks the same language and we have to learn to collaborate. So I want to finish this just to let you know that you should never let anyone feed you in a box if you don't feel like you should be in that box. Not society, not academic, nobody. You have the power to create your own future, your own way to proceed in your life. So use those blessings and just enjoy them. Don't let people put you in any type of box. Know that normal one, know that beautiful one. So that's all for me. I want to know, what do you think now? So if you have questions, I should stop presenting. I think stop presenting. Yeah, there you go.
All right. Thank you so much, Dr. Zaelzer, for the wonderful talk and sharing not only your amazing work, but also your personal story of how you came to where you are today.
Thank you.
One thing your talk really got me thinking about is that, today we're experiencing crazy amounts of misinformation on the internet. which is especially prevalent during the pandemic. I mean, you might have even heard of the term infodemic. And I think that strongly emphasizes the importance of the points you brought up about making science more accessible to the public, so that I guess it can like drown out all this misinformation. Because often misinformation is more emotionally evocative than sound science. So thank you for this important discussion.
But
Um,
it's
yeah, go ahead.
but exactly what you say, right? Like that's a big flaw that we have. That most of the misinformation use a lot of emotional tools,
Yeah.
and this means this. We are missing an opportunity here to talk about our science with emotional tools, and I'm not talking with about like go on passion and scream to people like, "Oh, science is the truth and you are stupid." It's not that. It's the fact that we are missing the opportunity to learn from these tools, to
Mhm.
use it to reach people, to create bridges of trust where you help people to understand better a subject. People is extremely smart. It's a big mistake from anyone in academy, in science, in knowledge, any type of knowledge, to think that the lay person is a person that don't understand. You
Mhm.
know, most of the people will understand the message if you are patient enough, if you come down from your high position of keeper of the knowledge.
Mhm.
So
Yeah. I think we should probably move on to the questions. The first one we got is quite a fun one. What is your favorite science art project that you have worked on?
what is my favorite science art project I work? You mean like the students? Oh, that's a hard question. Our students are so cool. I mean, they come with ideas that are incredibly interesting. Like, for example, the first year we got one of our students that she finished now a master in sculpture. She was working with one of our students in neuroscience that he was working in Drosophila visual system. And they create this set of sculptures done in wood that were representations of the visual cortex of the fly. And they were just like so beautiful and exquisite because she was using different type of wood to represent the different layers of the cortex and the different type of cells. And they were just triggering the conversation. People went to see these objects were like this size. They went to see these objects. And just because the beauty of them, it were triggering questions about what they were, where they were based in, and how science was informing this. Um, Last year, we have a group of students, four of them, who created an experience. You saw someone with boxes here and they were working in darkness. What they created was an experience where they were testing how the world work, like when your senses are shut down and how you operate in absence of senses when you are feeling for the sense of someone else. And that was to test how the human body experience, the lack of sense, and also to understand the role of synchronicity in neurons. So they were with these boxes where you could not see, but you were listen the sounds that other people was feeling, and even feeling the movement of the other person because they were putting sensors that will press a little bit on you with electrical impulses to just direct, what the other person was doing. And in some point, if you arrive exploring the space in certain area, both the three or four people will be connected and synchronized. And that was just to represent how neurons work together in synchronicity to provoke things like movement. This was from our research based in Alzheimer. And so on. I could be all night talking about the brains of the students. They are so creative, and always they go, the extra mile. You are expecting this, and they go like 1 kilometer away from what you were expecting. Extremely creative people.
It sounds crazy. It sounds like there's a lot of technological aspects too in that.
You have mixes. You have for one side, for example, what Pamela was doing, what I was telling you before, was wood sculptures. So there was a lot of handsing. She do everything, cuts and all that with her own hands. She don't use laser. The other team was using extremely high tech and coding and all that. And we have this mix of things from people that really use tactile things that you
Mhm.
see like a painting to people that go to digital arts. So And this is cool because when our students start in this, especially neuroscientists, they usually go with this idea, oh, this is going to be a painting or a sculpture, and now they know, seeing the work of Convergence, that the yes, exactly. There's a lot of different things that can be done.
Yeah. One question that I personally wanted to ask you, someone who's always had an affinity for art growing up, but has yet to incorporate it with my academic science life, what advice would you give to someone who wants to start intersecting art and science?
First, start enjoying art by yourself. Like just take a pen, produce something. Just like don't one of the worst things that happen with people that want to do art is that, especially when we are scientists, we scientists create these structures of how things have to be done. This is the protocol. I have to first buy the pen, buy the paper, and all this in order to do a drawing. And my drawing have to have this standard. That's BS. Take all that, put it in the garbage. Just take a pad, take up any pen, and just draw something. Or if you don't like drawing, take clay, or just take objects around you and do things. And then once you start to do things, when you feel comfortable, when you destroy this fear to try new things, you can start to see how you incorporate this into your science. And it's different methods to do that. It's different methods to inform actually how science can be translated to materials, and materials can translate to emotions. And I will take the opportunity to say this. We will have in a couple of months more a couple of workshops on that, in how to go from science to materiality, from materiality to emotionality to art. So it's not difficult. It's way more simple than you may think. So I extremely encourage anyone that wants to do something, just go and do it. Take a class, go watch a video, and just try it. Just try it.
All right. Thank you for that. That is as good as advice I need to hear. We have more questions, 2 logistic questions. 1, how are students selected for the program? And 2, are students taking other courses while in this program, or is it their entire course load?
Students are taking more courses. So all our students are actually, half of the class is fine arts students and design students. And half of the class is grad students in neuroscience or science. So they are taking other courses, first of all, or they are doing actually PhD thesis working in a lab. So it's people that is pretty busy. So and still they're able to go ahead with the course. What are the requisites to take the course? You have to be in Concordia University or in a university in Quebec. So this way you can take the course through CREPOC system. We are trying to open now this year because the pandemic. We were able to get some people from Alberta, from Edmonton. One person is from Edmonton taking the course. That's exceptional. This is the first time that happened, and this is thanks to the pandemic. So hopefully we can continue doing this. Now, this course is every year, like as experimental it is. We have a lot of people also that's trying let's stop this because we want to use the credit for other things. So every year we fight to continue doing the course, and so far we have been successful 4 years to do this. So yeah, that's what I can tell you right now about requisite. And requisite is like you want to do the course. Like we really don't reject anyone if you want to take the course. Our only requisite is take the course and finish it. You cannot drop the course in the middle because then remember that you work in teams. So if you drop, you let the person alone, and that kind of make the things complicated.
Mm-hmm. Yeah, I can imagine. Our next question is, how would you recommend scientific communities to incorporate/understand the connection of arts, especially when most scientists are quite secluded from arts and don't have that bridge perspective?
Could you repeat the question, please?
All right. So it's asking, how do you recommend scientists to basically connect with the arts when most of them are kind of secluded with the arts?
Okay, so that's a really good question. Look, during the last month, I was involved. I was lucky enough to be involved with an initiative that's called Falling Walls. Is this initiative happened in Berlin, and they do every year a summit of science, and they call for projects to being part of something that's called breaking walls. And they have one particular category that's called science engagement. And in this category, we were selected from all the people that applied. That was tons. We were selected 112 projects, from which they choose at the end 10, from which they choose at the end 1. And all to say that these 112 projects were 112 different perspectives of how you can engage the public. And they were just fascinating. Like, my perspective is using art because you bring back emotionality to the practice of science, and it's just like a base to start to talk about emotionality and to use different resources. And in art, you can speak about storytelling, about performative art, about play, about creation of games, about anything that is plastic, that you can create something that engages you, all the other senses, can be used to communicate science. Now, this is again not a one hat fit all, right? We were talking just about boxes. This is exactly the same thing. If you are a scientist and you like this idea, you take this idea, but it doesn't fit everyone. You will have scientists that will not like the idea of use art just because education or background, or they just don't like it, right? But if you like it, there's tons of different. It's a huge spectrum of variety that you can use to create this engagement. And this engagement can go from just talking in your institute with something like, for example, a photography contest, to really go and reach the public, school kids, adults, seniors. You have all the different spectrum and avenue of possibilities to do things. It just depends on what is your idea and how pushy are you with the idea. And resources exist today. There's many different initiatives around the world doing things where you can take examples and you can communicate with people that's doing this kind of things too. Like, we get all the time callings from people that want to do things, and we help people to process some ideas and see how they can make them successful. So yeah, I don't know if this answers your question, or
I
at
hope
least gives some guide.
that answers that question. I think so. So for time's sake, I think we'll go with one or two questions more. The
Sure.
next one, what are some barriers you have personally faced while working in the science field?
What's some barriers? The biggest barrier I face is English. Um, the story I was telling you before, like, you can imagine that coming from a country like Chile, from the situation I was, we never have the resources to pay for English classes. So I learned English by myself. I learned English translating papers. So the first time I came to the United States actually to do practical work for my thesis, this was in 2007, I was speaking literally like Tarzan. And from there, yes, my English has improved a lot. I'm able to communicate, I'm able to write and all that, but I will never be 100% fluent. Uh, and I have tons of barrier with that and tons of issues with that, because a lot of people criticize my English, and or I don't feel I'm competent enough to write, for example, a good grant or things like that. So this is the biggest issue for me, my English. Uh, then what other issue I have? That people sometimes don't like my ideas, but that I guess we all, I guess we all have that kind of issue, right? Like, we cannot be loved by everyone, or everyone will not like the way that we approach some particular problem. But I would say that the first one is the most important one. Here in Canada, being gay is just amazing compared with being gay anywhere else.
That is
So
true, yeah.
coming here as a gay man is like, it was like, whoo, awesome. If I come back to Chile today, I have no problem. Like, everybody knows that I'm gay and all that. But came out of the closet was never possible in Chile because I was afraid.
Mhm.
And I had to finally leave the country to go to do my PhD in another place, to being brave enough to do it. And today exists, it's so much advanced, guys, so much advanced that we have done in this issue. Canada is an incredible place to be to have this freedom, which doesn't mean that the fight has to stop. This doesn't mean that you should be comfortable and don't recognize that you have a privilege with this, and you should use the power of what you have been given to help other people. Today, like, yes, gay people in Canada, most of the people don't suffer things. Still is attacks and things like that, but most of the gay people is safe here. But our indigenous communities are not safe. Women in science still doesn't have representation. Black people still don't have representation. And these kind of people, especially you as someone from a minority, like myself as a minority, I should think that I have the responsibility, because I experienced that kind of rejection, to help anyone else and consider anyone else my brother, my sister, my sibling, to help that person to reach a position where they also can enjoy the privilege of knowledge, enjoy the privilege to being, here. So it is really important, especially in a world where we have become so individualistic, to realize that we are a community, and we have to be a community and work as a community to help each other, because that made better nations, that made better societies. So yeah.
That brings up another reason that art is important as a communication tool, because it crosses all language barriers, right? So even if your English isn't perfect, you can communicate with art. That's your strength. So I think that's beautiful.
Exactly. You are absolutely 300% right.
Okay, since it's 5:30, I think we should probably close up. So thank you to everyone who attended today and contributed questions. I hope you all enjoyed the discussion as much as I did. And a big thank you to Doctor for your time and ideas. It was a pleasure to have you. And I wish you all a nice evening.
Thank you so much. If you guys want to follow me, just find me on Twitter, add me. My handle is Eolo, EOLOSON. So if you just want to add me and continue conversation, I'm there so we can continue talking about this. Thank you so much for the invitation, Mina. You guys are doing an amazing job. Thanks.
You too.